Okay, so I want you to note the outset, this section, there are an unbelievable amount of vocab words. In fact, there are like 60 words. So that means you can't, for those of you like try to blow off vocab, you literally cannot do this unit without it. I'm going to throw things in like adjacent angles, vertical angles, complementary angles, supplementary angles, alternate interior angles, alternate exterior angles, all these different things. Not just having heard the word, you have to know what the words mean, how they interact, the fact that alternate interior angles are equal, the fact that vertical angles are equal, the fact that supplementary angles equal 180 when added together. And all these things, you have to be able to recognize them and know the rules between them, so you have to memorize and spend the time with this. So there's a lot here to do, so we'll be discussing this, and again, I expect you to write this down and spend time nightly learning the words and how they interact and what they mean. This first chunk here is just a review of some basic geometry. I think I have a total of like 17 words or 16 words in this section. So there's some here, and then there'll be some more that are new, probably new to you. First term, I know you've heard this one before, is point. And so a point is the most basic geometric figure, has no actual size or dimensions. Now, that's a tough idea, but it technically doesn't. Represented by a dot and named with a capital letter. That's important. So like point A. Points make up all the shapes, whether they be squares, or, rhombuses, whether they be trapezoids, any number of things that we're going to talk about, and 3D figures. Next concept, here's a line. It is technically created by 2 points. Well, it's an infinite number of points, but you name it with 2 points. So it has no thickness, but does have length. Naming lines. So this one I can say line AB. Please notice here and here on the ends indicate this line goes on forever in both directions. So I name it AB. I could also name this one BA. That wouldn't matter. Lowercase script can also name it, so I could call it line L. And then you don't need the points. You can just call it line L. Part of a line. And again, you can pause here if you need to catch up. Part of a line is a segment, a section of a line with endpoints. So 2 capital letters. Notice no arrows. Like over here on the left side, it had arrows on the end. Here it doesn't, because it ends line A, B, or line segment, I'm sorry, A, B. You could also call it BA. A plane is a flat surface that extends indefinitely in all directions, usually represented by a parallelogram. And you can name it this way, like plane ABC, or plane P if you prefer. So again, you could call it plane, and you can represent it by a parallelogram like this. And this one you would call it A, B, C. Or you could call it plane P. Now, a ray you can consider kind of like half a line, but it extends indefinitely in only one direction. So this one is ray AB. Not BA, because the first letter indicates that the endpoint, where it starts. So like this one over here, the one on the right, you would not call it ray OP. It would still be ray PO, and you still point it to the right, even though technically this one points to the left, right? So it's still PO. You could not call it OP. That's an important distinction. It's important that you understand that. Always begin with the endpoint. The arrow always points to the right, no matter what direction it's going here. Now again, as I've noted, there's a lot of vocab here, right? This one's 19 slides. You can always go back and review this at any point and hear me discuss it, hear me talk about it, not try to go, oh, what did he say about that? Because I'm doing it right here. We also have parallel lines. You might have heard of these before. Lines in the same plane, that's important by the way, that never intersect. If the lines are not in the same plane, we would call them skew. We'll get to that. But if they're in the same plane and they never intersect, they are called parallel lines. And there's a couple of symbols we have to note here. Notice we have line CD right here. Notice the arrows on the end. Line RS. And again, the arrows on the end. These two lines going up and down mean parallel. It says CD is parallel to RS. You will also notice on the actual lines themselves, there's little arrows right in the middle. Those mean those two lines are parallel to each other. So those indicate parallel lines. And when I draw those, I might go something like this. I might go, and again, put your arrows on the end, and my arrows in the middle. That's the way I draw those. And then label them with the points that you have on there. The bottom here we can see, we can also again use that lowercase letter, so L and M. L is parallel to M. That's how you read this. That's what these mean. Again, the little arrows here indicate those two lines are parallel to each other. Even if I don't draw them looking very parallel, but I put these arrows on there, it means they are parallel. I mentioned this before, skew lines. Lines that are not, right, not in the same plane and never intersect. They're not called parallel because they're not in the same plane. So like L and M here, notice here's the plane for L, M goes through a different plane. They still don't intersect, but they're not considered parallel. They're called skew, S-K-E-W. So here's a little quick quiz yourself of what we've done so far. And there's still some more in this one to keep going with, so like 10 more. Name a pair of parallel lines. So now watch my arrow. So CD is parallel to AB. CD is also parallel to EF. Notice they're in the same plane. You could say DF is parallel to BG. So there's a ton of them on here that you could pick. Lots of parallel lines. Now you could not say CD and BG are parallel, but they would be skew lines. Notice they're never going to intersect. But if you continue that BG on forever and ever and ever, right, like this, and you considered CD, and again, if you hopefully you can see 3D, right, they don't actually intersect here, so those two would be skewed to each other. You could say that. That's that third one here. And a pair of parallel planes, so we could go back here and we could say that CDF, and you could call it CDFE if you want to, is parallel to the one on the back side, ABG. So the back side of the box is parallel to the front one. So that's what we're looking at. Stop and check yourself, quiz yourself real quick, see what you understand that we've done that. If not, you want to stop, maybe ask some questions. Or go back and review the vocab. So, now this is the stuff that's going to probably be new to you. Today's homework, or the first day's homework, I should say, whatever day it ends up being, is going to be based on this stuff that's coming up. Now the previous words are going to be on your quiz and test, though. Okay, so we talked about rays, right, having an endpoint. So like here, of ray BA, ray BC. Again, remember, it's not AB, it's BA and ray BC. An angle is formed by two rays, side with a common endpoint. So right here, this is the vertex, and the vertex is a point, and it's going to be point B. The sides are two rays. So we have ray BA and ray BC. Notice they start with the same letter since that is their vertex, B. You could also name it. Now again, we're gonna name the angle here. We can name the angle, and we usually go in order. So we'll start like here, A, B, C. You have to go in order. The vertex has to be the middle, or CBA. Now I know it looks like I'm going backwards on the ray. I'm really not, because now I'm talking about naming the angle. So, and we'll use an angle symbol, so we can either say angle, right, A, B, C, or angle CBA. Sometimes we can also number them. So you could also say, well, that's also angle 2. Okay? So, again, angles formed by two rays, the common endpoint, or the vertex. This part's kind of important because I know this question actually appears on my test as a question. This right here, just with the angle DOG, represents an angle with a vertex of O. If I throw an M in front of it, that represents the measure of an angle with vertex O. And again, here, that has to be between 0 and 180 when measured with the protractor. So this is measure of angle DOG. This is just the naming of it, angle DOG. So this one, if I put this down, you'd have to give me a number, like 45 degrees, or whatever the degree happens to be. You may have seen this before. 4 types of angles. An acute angle, right, smaller than 90. Some people go, oh, look, they're cute because they're smaller than 90. Whatever. Obtuse angle, greater than 90, so bigger than 90. A right angle is exactly 90, not around 90-ish, exactly 90. And a straight angle, this might be a new one to you, it's a straight line, right? Exactly 180 degrees, it's a straight line. Straight angle, straight line, makes sense. Okay, so now this term, the word is congruent. It means that two things have the same measure without actually having a numerical value. So I just say that they're equal. So I would say this one, notice line segment, there's no arrows on the end, and line segment, right, P, Q, and ST. If I use this symbol right here, it looks like an equal sign with a squiggle. That means they are congruent. They are the same length without me actually having to give you a number. So if I said this is 10, but they're equal without me actually having to give you a number. Similarly, with angles that have the same measurement. So notice here, again, angle A, angle B. We can use that single angle, naming it by the vertex. Now remember the M from previously. Measure of A is equal to measure of B. But if I don't use the M, I have to use the congruency symbol. You don't use both at the same time. So angle A is congruent with angle B, this one says. So top one says measure of A is equal with measure of B. The bottom one says angle A is congruent with angle B. They have the same measurement without actually giving you a number. Okay, now then we get to some important stuff, and this is on today's homework. Vertical angles. So it's vertical angles. Angles that are formed by intersecting lines and are opposite of each other. So what that means, and by the way, before I forget that, vertical angles are congruent. So this angle right here and this angle right here are equal because they are vertical. I don't have to give you numbers. I don't have to tell you anything else. When I take two intersecting lines, like these, the angles that are across from each other are equal. Likewise, this angle and this angle are equal. Notice we're using those arc marks to indicate equality there. So again, the ones that are in red here, the single arc marks, are equal to each other. And then the blue ones are equal to each other. Now you can't say blue and red are equal to each other. But again, the ones that are crossed, vertical, are equal. And you do have to use those words. You'd have to tell me those angles are vertical, therefore they are equal. Or congruent in this case. Now this next word I have to stress to you has nothing to do with equality. Two angles that share a common side are called adjacent. So this angle and this angle share this middle side. That makes them adjacent. It doesn't mean they're equal. It tells you nothing else other than they are next to each other. So adjacent, another way to say that is angles that are next to each other, share a common side. Now here's our first set of angles that have something to do with measurement. Any two angles whose sum is 90 degrees are called complementary. So any two, if I had a random 50 degree and a random 40 degree angle, together that makes 90, so they're complementary. Likewise, if I took a 90 degree angle, like say this one, right, and I divided it up, some random line, together you know that they're 90, so we would still say that they are complementary. Supplementary, or any two angles when added together, equal 180. So some random floating 60 degree angle and some random 120 degree angle together, 60 and 120, is 180. Likewise, if I took just some random straight line and I drew a random angle out of it, that means that these two angles, this one and this one, so this one, again, and this one, together equal 180. And the reason I know that is that I know that a straight line, remember straight angle is 180, so I draw this line coming out and boom, I get two angles that equal 180. That's the end of our first section of vocabulary. You'll have some homework over this. In fact, this should cover the first 2 days' homework and help us to have an understanding of what's going on there. We'll do the next section, we'll do some more stuff that involves parallel lines and what are called transversals. But this vocab will take care of the first 2 days.